Hello, good evening everyone. So today we are going to solve questions based on week 12. Please join peer deck so that you can answer there. Password for it is on your screen. So be ready with your pen and paper. We will solve questions whatever we learned in the last session. Okay, should we start now?
Yes, ma'am.
Okay. So see, there is a question. It says in the past. The standard deviation of weights of salt packages filled by machine was 40. To decrease the standard deviation of weights, the new machine is introduced. A random sample of 25 packages from new machine showed a standard deviation of 32 grams. Based on this data, what is your conclusion at the significance level of 0.05 on the standard deviation of the weights of the salt packages fed by the new machines? Okay, and some values are given to us. So, which hypothesis test you will like to apply there? So, try it. We have discussed such a things. Is there any question regarding the clarification in the questions itself? Is it clear what the question is? So some standard deviation is given to us, and we will be checking against whether the standard deviation is 40 or 40 not. Okay.
Ma'am, your screen is not visible.
Okay, is it done?
Can you increase the time by 1 minute?
Yeah, sure. Okay, so let's discuss the solution.
Ma'am, your voice is low.
Okay, is it fine now?
Yes, ma'am, fine.
Okay, so yeah, how to start this? Start with this question. So it was given there. Standard deviation of weights of the salt packages was 40, right? So according to the procedure discussed in the last session, what will be our first step? From the given context, we will decide what is our null hypothesis and what will be the alternative, right? So any what did you guys decoded for null hypothesis here? Will it be a 32 gram or what? It is given that there are 20 the sample size was 25, right? So n was 25 for us, and sigma is 40. They have said that, and from 25 packages, they got to know that standard deviation was 32, right?
Yes, ma'am.
So, what will we be checking there for 32 or for 40?
40.
So, our null hypothesis will be for 40, right? Why it is so? Because this standard deviation 32 came from this samples of 20 sample of 25 size, right? So our null hypothesis will be, let's say the standard deviation is 40. Fine. So what will be our alternative hypothesis then?
Less than 40, man.
Yeah, what?
Less than 40.
Less than 40. Okay. How did you decided less than 40?
Because it is expected in the question that it is not 40.
Is not equal to 40, greater than 40, and you directly said it's less than 40. Why it is so? Because from the
Because
sample size,
32,
yeah,
30, we came to know 32.
yeah, from the sample size we got to know that this standard deviation of the sample of 25, we got standard deviation as 32, which was less than 40. So our alternate hypothesis was this. Okay, then the next step will be about test statistics, right? So as we discussed, if we are checking hypothesis testing against variance or standard deviation, which test will be applicable here? So yeah, so what will be our test statistics then? it will be about obviously sample variance, right?
Sam.
Okay. So our taste statistic will be t is equal to s square. Okay. When will we reject our null hypothesis then? That is also like we have to set, right? Reject null when? Yeah. When would you like to reject null hypothesis? Yeah.
When null is true.
Okay. No, no. See, a taste statistic is t is equal to s square, right? So now we will be checking about the s square, but when to reject null and when to accept it, like what will be test for that? So we will reject our null hypothesis if this t will
T
be
less than C.
okay. Yeah, t less than c for some critical value c. Okay, as alpha is also given to us, right? Significance level they have asked at 0.05. So obviously we will be checking what the c will be, right? And we will compare it with s square. Do we have any idea about s square? So yes, we have given that the sample standard deviation was 32, right? So all set. Now if t is equal to s square, then what to do then next? If we have
Probability of S square less than C,
okay, so
given that.
yeah, alpha is 0.05, but actually alpha is probability of type 1 error, right?
Yes, ma'am.
So what type 1 error is? That says probability of rejecting null, right? When it was true,
True.
given that h naught is true. So if we apply all this stuff, then we'll be getting probability that t less than c, given that h naught is true. H naught is true means in this
When
particular
sigma
case,
is
sigma is 40.
less than 40.
No, h naught is true. That means sigma
Sigma is
Yes,
40.
is
yes, ma'am.
40, is
40, 40.
equal to
Yes, ma'am.
40. Okay. So uh, that means probability t less than c, given that sigma is equal to 40. Okay. So what will you do now?
Use CLT.
Yeah, s square less than will be c, and as we are going to apply chi-square according to uh, the given information, uh, we can have some rearrangements, right? So s square will be less than c square, let's say. Is it fine if I write like that? Because this is nothing but s less than c, right? Given that h
Ma'am,
naught. Yeah.
do we cannot go with the simple step that S square minus expectation upon standard deviation is less than C minus expectation of upon standard deviation?
Will you please repeat what are you saying? Like s square into.
Can we directly use the CLT not to do a squaring the both side or that?
Okay, how will you use CLT there? Like CLT uh, is kind of different thing. It will not help us to interpret anything. We have to interpret. We have to conclude about the thing, like whether the standard variation is 40 or not. How will you conclude from the CLT?
Yes, ma'am.
It's not about the conclusion, right? That's why we need a hypothesis. So,
Yes, ma'am.
fine. So s square less than c square. Then what to do? As we have decided to apply chi-square, right? So
Multiply by n minus 1 and sigma square.
and divide by sigma square, right? So do we have any idea about n there or sigma square
Yes,
there?
ma'am. N is 25.
Okay. N is 25, so this is nothing but 24, right? And what about is given there? Sigma is 40, right? H naught is true, or here given that is sigma is equal to 30. Fine. Or let's say it is true, so no need to write. Okay. So then we know one more thing, that whenever sigma such a kind of random variable will appear, it will follow
F
a chi-square
distribution.
distribution, right? It is the ratio of two variances. So by that we can say that it will follow chi-square. So we can just put all these values there. So n is 25, so this will be 24 c square by 40 square. Yeah. So that will be nothing but chi-square, right? With what will be our degree of freedom there? Chi-square is there, then degree of freedom will be there. That will be
24.
n minus 1.
24.
Hello, am I audible?
Yes, ma'am, audible.
Yes, ma'am.
Okay. Okay. So it will be chi-square less than 4c square by 1600. Is it fine? So like then it is nothing but the CDF, right? CDF for the chi-square distribution. So yeah, alpha is 0.05 there, and this is nothing but CDF of chi-square 24 at this point. Then what will you do? Do we have any information about chi-square there?
Yes, ma'am. Inverse is given. Inverse of
Inverse at 0.05 is given to us. So once we apply inverse on both sides, then it will be 0.05 24c square upon 1600. So while solving all this calculation, okay, this is given 13.85, right? So if you solve all this calculation, what did you get for your c square? Value of the c is, yeah. Have you solved it?
Yes, ma'am.
Will give you something 923.
Yes, ma'am. 923.33.
Yeah, 923.33. Now what to do with this c value? So just remember what we have decided as our test. Our test said that we will reject our null hypothesis if t is less than c. What is our t? S square, right? S square. T is S square less than c. So what is S there? S is sample variance, right? Sample standard deviation. So S was 32. And what about its square? So once we square it, will give us 1024, right?
Yes,
Yes,
ma'am.
ma'am.
So now 1024 is actually greater than 923 c, right? So S square is greater than c. So what will you conclude from that? What to do? Accept the hypothesis, accept null hypothesis, or reject it? Yes,
Accept me.
we will accept null hypothesis. Accepting means we are saying that this standard deviation is 40, right? Is there any doubt in this particular question? Okay. So what we did in this one, from the given question, we get to know that we have to test against the standard deviation, right? So from we said that the standard deviation was claim was 40 grams, but when 25 samples were studied or taken into consideration, this sample standard deviation comes to 32 grams. Now question arises uh, that whether the standard deviation is 40 or the claim is not correct, right? So we just say that null hypothesis saying that sigma is 40 and alternative is let it be less than 40, right? Then we decided our day statistics, which is nothing but S square we taken, right? And we will reject null hypothesis if this standard deviation value will be less than some critical value C. Now, how to find what is the critical value there? So they have asked at the significance level of 0.05. So we know that alpha is nothing but the probability of type 1 error, and we calculated what is the probability of type 1 error. And going through that, we come to know that, okay, this quantity, when ratio of two variance is going to be happen there, it will follow chi-square distribution. So using the CDF of chi-square distribution, we found out what is the value of C, and that came out to be 923.33, which is less than S square. So we will accept null hypothesis, right? Accepting null hypothesis means they are saying that, okay, so, the standard deviation is actually 40 grams. Okay. Is it fine? Should we move to next question then? Is there any doubt?
Yes, ma'am, got it, ma'am. Ma'am,
Okay.
can you please just explain the question once again? Wordings.
Yeah, sure. See, they have given that when sort packages were fed there, the standard deviation was 40. Okay. Then someone has taken some 25 packages from new machine, and they showed that the standard deviation they have measured, and it came to be 32. Now the question is, if it came to be 32, or when when checking with the 25 packages, it came to be 32. Now the question is whether is it 40, standard deviation is actually 40 or less than 40. So that is our hypothesis now, and
Okay, ma'am.
based on that we will check. Okay, so let's move to next question. There is solution is also given in the PDF. I will share with you this PDF. You can check here. Okay. Okay. So next question is, uh, sociologist focusing on popular culture and media believes that the average number of hours per week spent on social media is different for men and women. The researcher knows that the standard deviation of amount of time spent on a social media are 8 hours per week and 10 hours per week for men and women respectively. Examining the two independent random samples of 100 individuals each, if the average number of hours per week spent on social media for the sample of men is 3 hours more than that for the sample of women, what conclusion can be made from the hypothesis test, which is also given to us at a significance level of 0.01. So, what the question is about, now there are two samples. This is two sample test. This is there are two samples. One is about amount of time spent on social media by men and women. So the distribution is given to us for men and women, and then 100 samples was examined, and we got to know that the difference between the average time is actually 3 hours. So now the question is, the claim that average time spent on social media by men and women are same or not. So we will check our hypothesis against that. Okay. So it's for mean of the average time. So which test would you like to use there?
Z test.
Yeah, what? Z test, yeah. Is it done or should I increase the time?
Increase the time.
Okay. So let's discuss the solution. So how did you start with this? Is the question clear to everyone?
No, ma'am, please explain the question.
Yeah. Let's wait a bit. So it's given that a sociologist focusing on popular culture and media believes that average number of hours per week spent on a social media is different for men and women. So we are checking about the number of hours per week spent on social media for men and women. Okay. So the researcher knows that the standard deviation of amount of time spent on the social media are 8 hours per week and 10 hours per week for men and women. So what this information is about? So they says so we will have some samples and we will say that if my, let's say, x is a random variable which is denoting the average number of hours per week spent on the social media. Okay. If I say by men, then the standard deviation will be 8 and we will consider that it's normally distributed. Okay. So mean will be unknown to us and standard deviation is 8 for men. And there will be another random variable which will denote the time spent on social media by women, and that will be normally distributed with some mean, let's say new 2, and standard deviation 10 hours. Okay, 10 hours per week. Fine. Examining two independent random samples of 100 individuals each. That means they have taken 100, like examined the 100 men and 100 women. They got to know that if the average number of hours per week spent on the social media for the sample of men is 3 hours greater than sample of women. Okay, so they got to know that when 100 sample, like sample of 100 men and sample of 100 women was taken under consideration, and they have measured the average hours per week for men's group and for women's group, and then they found the difference that the sample of men, time spent by sample of men is 3 hours greater than sample of women. So on an average, they said that the time difference, the time spent by men and women is not equal. Okay, so we will be checking against that. Is it fine? Let me just. Do you understand what the question is about? They will check whether the time spent on social media by men and women are same or not. So let me just write it. Let's say exercise, and they have taken 100 samples. So let's say xi is nothing but average number of hours per week spent on social media by men, right? So they, and let's say yi's are also a random variable, the same thing, but by women. Okay. So rest of the part is same. Just this is the average number of hours per week spent by women on social media. Fine. So if they are random variable there, then uh, how many samples are we taking here? So it is also given there. And one more thing, xi is let's say normally distributed. and we will also consider its IID samples, and normally distributed with, let's say, mean mu one and variance. It was given 8, right? For men, it was 8. Fine. So generally, we have standard variance here, so I am writing here 12. And what about YI? So they are also normally distributed. Let's say some mean mu2 and variance 10 square. Fine.
Yes, ma'am.
It was already given. Now, they have taken 100 samples, so I and what if I say J here, so the range for I will be 1 to 100 there, and similarly for J. Then they have also informed that if x1 to x100, like this was for 100 mils, they observed the time and found out their average, and similarly they checked the average for 100 women and calculated the difference between uh, the time spent on social media by men and women. That is nothing but, should I say that it is nothing but the difference x bar minus y bar modulus.
Yes, ma'am.
As they said, the time for men was more, right? 3 hours more. So is it fine now? So that was given information. Fine. They have taken 100 individuals under consideration for men and women. They found their average time, that if 100 men are considered, then what will be the average time spent on the social media by men, and considered 100 women, and uh, calculated the average time spent by the 100 women on a social media, like in terms of number of hours per week. And they found that the difference is 3 hours per week. Okay?
Ma'am,
Yeah.
ma'am, is the difference between the mean of the x and y is given at the 3?
Yeah, it was given there. See,
Okay, ma'am.
it's not directly written there, but this. See, they said that examining two independent random samples of 100 individuals each, if the average number of hours per week spent on social media for the sample of men is 3 hours greater than that for the sample of women. Okay?
Yes, ma'am, got it. That means if we take the men will be x, then x is equal to 3 plus y. Then
Yeah,
x minus y is equal to 3.
not X, it's the average of that sample.
Yes, ma'am, x
So
bar.
X bar,
Mean.
right? Yeah, me. Then, so the question is about the claim initially was about whether the time spent by, like average time spent by an individual man and individual woman is same or not. So what should be my null hypothesis, even though it was given in the question, but I think with this given information also you will be able to decode null hypothesis and alternative. So the question is about mean, right? Whether these mean time is same for both or not, right? So our null hypothesis will be, let's say, the mean mu1 and mean mu2 are same, and alternative is about,
Not equal to.
yeah. So if we are checking about the mean, then what should be our taste statistics? T,
Sample mean.
sample mean of, but here there are two sample, right? It is a two
X
sample
bar
T.
minus y bar, then
Difference greater than C.
Yeah, difference between them.
difference.
Is it fine if I take this difference? It may be possible that y bar will be greater than x bar sometimes. So on a
You can
safer
take
side, I am
mod.
taking this. Okay. So modulus T, is it fine? So when will you reject your null? That should be decided earlier, right? Reject null if, what would you say? If the modulus is greater than some value C, right? The difference will be, if the difference will be so greater, then we'll say that no, the average time is not same, right? Is it fine? Or difference should be less than C? What would you say on this? If you are considering any sample of these, like two samples, let's say 100 men's and 100 women's, and you got to know that the difference between the average time spent by men and women is 3 hours or 4 hours for your particular sample, then what would you say? If the difference is greater than some number, let's say 10 hours, then we will say that okay, the average time will not be same for them. The time spent by men and women will not be same, right? If it is like the difference will be 1 hour, 2 hour, then you will say okay, it might be depend on particular sample. If the sample is more representative of for this, then the answer might be different, right? Are you getting my point?
No, ma'am. Ma'am, please explain about this rejection condition, ma'am.
Yeah, which condition?
Last one,
Rejection.
if this mod of T is greater than C.
Okay. So just assume that you are only the searching on this topic, uh, whether men or women spend more time on the social media. Okay, we are doing the research, the studies on. Then in that case, in statistics, what do we do? So there are like many men's and women's, right, in the world. So we cannot check everyone's every individual's time spent on social media, right? In terms of hours per week. So what will you do? We will take some sample, right? Let's say we have considered two samples. This sample S1 and this is sample S2. So what they are? This is a sample for men's and women's. Okay, and you got to know that you have just averaged, like in this particular one, they have uh, taken under consideration 100 men's and 100 women's. Okay, and they measured their time spent on social media in terms of number of hours per week. Okay, is it fine? And they, so we will not check one by one, right? It may be possible in your sample, one person, let's say one male, is using too much social media, and in the same sample, you in the woman sample, you got one one lady which is not even using social media. Then your sample is not random and will not be the good representative for your conclusion, right? So what we'll do, we have taken samples of 100 men, and that will be a random choice. Okay, in that it should be a good representative. The representative means it should contains men's of different, let's say, profession. Okay, and after that you will note their time spent on social media, and average will take average of the all the 100 men, average of time spent on social media by that 100 men. Fine. So you will get some number x bar. Is it fine? This is how we decide, right? That what is the average time spent on social media per man if the 100 men are considered. Is it so? Right?
Yes, ma'am.
So similarly, we done the same thing with y bar. Okay. Now, the question was whether the time spent by men and women are same or not. So we are dealing with the average only. So we will just the simplest way is to check this is you will just x bar minus, you will different find out the difference between these means. Okay, and you got to know that this difference is, let's say, 5 hours. Okay, then what will you say? Will you conclude from the sample of 100 men and 100 women that the let's say in this particular question the difference is 3? Okay, and it was actually they say that men are using more, spending more time on social media, right? X bar minus y bar was given 3. That means the average time of 100 men spent on the social media and average time of 100 women who spent time on social media uh, hours per week. The difference is 3 hours. That means, will you conclude from this setup, from this much information, that every man is using more social media as compared to women? Will it be a good, what we say, conclusion? By just studying 100 men, a sample of 100 men and 100 women, will it be okay to conclude anything? No, right? If we are doing that kind of thing, then this study, let's say, is studied by some one person. If the same study the second person will do, then in that case, he or she may get x bar, y bar. The difference is, let's say, some 4 hours. So for that, we should have some window for this difference, right? It should not be like if it is 3 and 4 hours and we are claiming that the difference, like the time spent on the social media is not same for them, right? And it's very rare that when you will get x bar minus y bar is 0, right? That means the time spent by the 100 men and time spent by, like, time spent on social media by men and women are same. So for that, we should have some critical value which will say tell us that if the difference is less than some c, right? In that case, you will say that okay, their time spent by them is almost equal. So if this difference will exceed some limit c, this 3, 4, or it may be any number, right? When we check it with some particular what we say confidence, then this critical value may change. So at the fixed significance level, the c value will have some value, let's say 5 hours. So if the difference of this average will increase by 5, then we will say that okay, the null hypothesis which says that their average time, the time spent by men and women on the social media is same, is incorrect, because the value t, the difference between the time has exceeded this critical value. Is it clear, or still there any doubt?
Yes,
So
ma'am.
it may be possible that, for example, if there are 40 students and they are doing the same research, right? So obviously their sample will not be same, right? The sample size, which 100 men they are selecting, they will be different, right? And depending on that, their difference, their x bar and y bar values will be different, because their sample sizes are different, because their samples itself are different. So we should have some window for this difference, right? So that's why we say that if the difference of x bar minus y bar will exceed with some value of c, in that case we will reject null hypothesis. That means we will say that the time spent by them is not equal, because the difference between the average time is too much, right?
Yes, ma'am.
So now, according to the two test, what should we do now? We said that our taste statistics is x bar minus y bar, and we know that x bar is and y bar are following normal distribution, right? Let's say with mu1 and 8 square, and y bar is following normal distribution with mean, let's say mu2 and 10 square. Fine. So what will be the distribution of x bar minus y bar? So if x and y are normal distributed, then obviously the difference is normally distributed, right? So what will be the distribution for t?
Normal.
Yeah, normal. And what will be their mean and variance?
Mu1 minus mu2
Mhm.
and 8 square sigma square divided
Yeah,
sigma 1 square divided by
8
n.
square upon n.
Uh,
N is given to us, right? 100.
Mm.
And this is 10 square by 100. So, okay, this is nothing but 164, right? $100, that is our sigma square. So now what to do? If this is a normal distribution with this sigma square, can I make it a normal distribution with mean 0 and variance 1? Is there any chance that I can have this distribution to be a normal distribution with mean 0 and random variable? Sorry, variance 0, variance 1. So
If mu1 is mu2.
yeah. So let's come up with the significance level, which was they have given it with 0.05, right? 0.05. So alpha is what? Actually, probability of rejecting null, given that H naught is true. That means null hypothesis was true, but we are rejecting it. So that is probability of modulus T greater than C, given that mean are equal. So once their mean are equal, that means mu1 minus mu2 is equal to 0. So if I take minus 0 on both sides and divide with the, what we say, sigma t, sigma square t or sigma t, right? Sigma t is what? The variance, like standard deviation. This is nothing but sigma t square, let's say. So that will be greater than C minus mean upon sigma t, right? So do you remember such a things? This is nothing but the, now it is normally distributed thing. Right? And there's nothing but with mean 0 and variance 1, right? So may I write it as what we say, modulus z is greater than C upon sigma t. Why I'm writing z there? Because generally we say standard, yeah, standard norm, right? Okay, sigma t is also given to us, right? That is 164 square root of 100 upon 164, right? That's it. So how to do with this now? Modulus z is greater than this value, then CDF format. Can I write is this is nothing but probability that z is less than minus C of square root 10 by square root 100 by 164. Okay, you can say. No problem. Okay, is this value given to us? This CDF value? Force times C, right? And here we have 0.05. So there was one value given to us that was fz of 0.005. Oh, it seems alpha was given 0.01, right? They have asked the question for significance level at 0.01. Okay. So now taking the inverse and what will get then? Yeah, fz inverse is given, the value is given to us. So 0.01 by 2 will be 0.5. 164 C. Yeah, what was given, the value was minus 2.57, right? And solving this will get a value for C, and that is nothing but something 3.29. Okay. So the value for C is 3.29. What is C? What C was actually what for? Modulus T, right? If modulus T is greater than C, then in that case, we will reject our null hypothesis saying that the time spent by men and women are not same. So the difference was given to us, right? Modulus x minus y, like x bar minus y bar was given 3. So what should we do now? What should we conclude as our, yeah, modulus T, yeah, y is 3, that implies 3 is less than C, right? Which is 3.29. That implies accept null hypothesis. Okay. So just tell me if there is any doubt. So the main task is to understand the question. Once you read the question, rest hypothesis test to decode which test we should apply, that thing will matter. So just tell me, is the question and solution clear to you? It was given that we were searching for the time spent by men and women on the social media, right? So to check whether the time spent by them are equal or not, researchers have performed some test. They have considered 100 men's and 100 women's, and they calculated the average number of hours per week by men and similarly by women, and subtracted to get the difference. So they found that the difference was 3 hours. So, and they also researched that the average time spent by the men has standard deviation, like it was normally distributed with some mean and having standard deviation 8 hours per week. Similarly, for the women, it was 10, like the standard deviation was 10. Now, the question is whether the time spent by them, men and women, is same or not, because by the sample of 100 individuals, they found that the difference is 3 hours. So, to check that, we have uh, performed a hypothesis test, that is 2 samples that test with the significance level 0.01. We got to know that that the from this setup, we concluded that the time spent by men and women is same on social media. Okay, so we did what we did. We just had two random variables, xi's and yi's, which are denoting average number of hours spent on a social media by men and women. Okay, and we formulated in this distribution pattern that they are independent and identically distributed normally with some mean and with some with standard deviation which was given to us. Then they also told us that the difference by the average 100 average of number of time spent by men and women of 100 sample was 3. So we had our null hypothesis as the time spent by them on a social media is equal, and alternative is says that it's not equal. So we decided our test as if the modulus t, that is difference, is greater than some value c, that is critical value. We solved the further things and got to know that it is the value of C was 3.29, which was actually greater than the difference given by that 100 samples. So from that, with this support, we will say that we will accept our null hypothesis and will conclude that the time spent by men and women on a social media is equal. Okay. So let's move to the next question. If there is any doubt, you can unmute yourself and the solution is here also. Okay. So next question is about manufacturer of the new car claims that typical car gets a mileage of 36 kilometers per liter. Okay, this is claim. So obviously we will be testing against this claim. We think that the mileage is less. To test our suspicion, we perform the hypothesis test with this null. The mileage is equal to 36 or less than 36. Suppose we take a random sample of 100 new cars and find that their average mileage is 36.4, greater than that, kilometers per liter, and sample standard deviation is 4. What does the t-test say about the null hypothesis with a significance level of 0.05? So just tell me what the question is about. Can anyone explain it? Or is it clear to you? So the claim by new manufacturer, it says that let's say there is some launch of new car and manufacturer says that the mileage is 36 kilometer per liter. So obviously people will not believe on that claim, right? They have to taste it against some whatever the question they have. So someone said that no, the mileage will not, 36 is too much, mileage will be less than that only. So they checked their null hypothesis. They said, okay, if they are saying 36, so let's say null hypothesis is 36 and alternative is less than 36. Okay. So either it will be 36 or less than 36. Okay. Either the claim will be true or the suspicion, whatever people have said that, okay, mileage cannot be 36. Okay, it might be less than. So there is two things, either null will be true or alternative. Fine. Then to check it obviously we will take some random sample. Let's say they have taken 100 new cars and find their average mileage, and they have calculated the mileage of 100 cars and take the average of them, and they found that it is 36.4, and sample standard deviation for that, for the same thing, is 4. So according with this information, obviously we know that we are going to use t-test. So at a given significance level, what will you do? Will you accept null hypothesis or reject it? Okay. So obviously we will be having some value c. If if the test statistic will be greater than less than that c, then we will reject our null. Right? Is it clear?
Ma'am,
Yeah.
this rejection of the null hypothesis, that will be similar to whatever the condition is given for the alternative. Like t should be smaller than c, where this mu is no smaller than 36 for HA.
Hmm.
So do we decide it like this? For the alternative, that mu is suppose smaller than 36, so the capital T will reject the H naught when T is smaller than the C. Will it be
Yeah.
like it?
Yeah. Or you can think it like this. Okay, let's say yours, if we consider t greater than c, then what will happen? Just think of it. Where what's our target? Our target is to check whether the mileage is 36 or less than 36. Okay, and the hypothesis is about sample is about mean. So obviously our test statistic will be nothing but the sample mean, right? X bar, or t is equal to t will be our x bar. So if the sample mean will be greater than something, then how will we reject the null hypothesis? We have to reject it, right? At what c will you reject? So if that x bar will be less than some value c, then only you will say that okay, the mileage will be less than 36. So
Yes.
yeah, these are the practical situations where we use this kind of stuff. Okay, so greater than c will not work. Do you understand that?
Yes, ma'am, that is what I was asking. Yeah,
Yeah,
I
yeah.
understood. Yeah.
So null and alternative hypothesis is given to us, and test statistic also we discussed that it will be something about sample mean, and that is also given to us, and with 36.4. So the test statistic will be we will reject our null if it is less than some value c. So the task is to calculate the value of c. So for that we need the at least we need the significance level, which is given 0.05. So solve it and just find what is the value of c, and based on that what will you do is decided, right? If the c value of c like 36.4 will be greater than c, then what will you do? Or if it is less than c, then what will you do? And can anyone say that why we are using t-test here? Why not z-test?
Standard deviation is not given, ma'am.
For what? Yes, sample standard deviation is given to us, this 4. Then why? Yeah, population standard deviation is unknown.
Yes.
Yes, correct.
Variance is unknown.
Yeah, variance is unknown to us, the population variance. So you can unmute also and speak there. But please don't write answers on chat. You can join the peer deck and check it. Okay. So is it done? So let's discuss correlation. Yeah, null hypothesis is given to us. It is 36, right? Okay. And alternative is less than 36. So what will be our test statistics? If we are checking against mean, so obviously the t will be x bar if xi's are your random variable, and if sample means, so reject h naught when, or if let's say t is less than some value c. Okay, so alpha was at 0.05. And how many samples they have studied? So x1 to x100 samples they have studied, and say that the standard deviation S is 4, right? For this particular sample, 100 samples. So in that case, alpha, which is probability of type 1 error, will be what? It says that it's the probability of rejecting null when it was true, right? So rejecting null, that means probability t less than c, right? Given that it is true. H naught is true means here mean is 36. Mean is 36. So as variance is not given to us, I will just subtract it with our mean, which is 36, and divide it by, instead of sigma, we will divide it by, yeah, what? S square by n, right? Isn't it? We do the same thing, right?
Yes, ma'am.
S square by n. Okay. So just put all these values there, and it's t minus 36 upon s square is also given to us. Some 16 by n is 100. C minus 36 by square root of 16 by 100. Okay. So we know that this, again, this random variable will be a, yeah, this will follow F distribution, right? T distribution. With the degree of freedom will be what?
35.
99.
Yes,
99.
90. Okay. So that is nothing but FT99 of C minus 36 by Okay, we can have it 4 by 10. So 10 like this. Okay. Is it fine? And what is the value of alpha there? It was at 0.05 significance level, right? So just take the inverse on both sides, and that value is provided to us. So inverse of t distribution at a point 0.05 is equal to 10 by 4 times c minus 36, right? And then yeah, we just solve it and we'll get the value of c as 35.34, right? And okay, once we got the value of c, then what to do?
We'll compare it to
Was anything given about the sample mean?
yes.
So revisit the question. X bar was given as 36.4, right? So now if sample mean is 36.4 and the value of C is 35.33, that means P is actually greater than C, right? Here
Yes. So we'll
P
not
is greater than C. What will you conclude?
will not reject. We'll accept.
Accept the null. Accepting null means we are saying that the mean is 36. The mileage will be 36, right? Okay. So this is the way how we check any claim given by anyone statistically. Okay. So we just have our hypothesis, null and alternative, and we'll decide our taste statistics on which basis we are going to taste it, and there should be a one fixed significance level so that we'll calculate the value of C, and on the basis of the value of C and the given sample, what we say, using that sample, we will decide whether to accept or reject the null hypothesis. Okay. Is there any doubt regarding this and this question or any of them?
Ma'am, C is
Yeah.
less than 30, so how accept? Like,
Okay. So just check what was our taste statistic. It said that if the value of t, which is x bar sample mean, is less than c, in that case we will reject. Here t is not less than c, it was
okay,
greater than c.
okay.
Okay. Next one. Okay. So an IITM instructor conducted 2 live sessions for 2 different classes. Call it A and B in statistics. Fine. Session A had 25 students attending, while session B had 50 students. The instructor conducted a test for the 2 sessions. Although there was no significant difference in mean grade, session A had standard deviation 12, while session B had standard deviation 15. Can we conclude at a 0.05 level of significance that the variability of marks of class B is greater than that of A? So, would you like to explain the question, anyone? So, you can unmute yourself and so basically it is a 2 sample test, right? They have conducted 2 live sessions for 2 different classes. In A, there are in session A there was 25 students, session B there were 50 students, and then conducted a test. And in test, the standard deviation for a class A was 12 and standard deviation for class B was 15, right? Now they have given a significance level and asking whether the variability, that means the difference in marks of class B is greater than that of A or not. So how to check it is? So what will be the null hypothesis here according to?
Mm, mu1 equal to, it's not equal to mu1 equal to mu2, ma'am.
Okay. Are we going to take any average kind of things?
We are no, we are testing the variance actually. The
Yes.
s square x divided by y square f test is good.
Yeah, what?
And we are the ratio of the variances are going to be tested now. S square x divided by s square y.
Okay, okay, fine. But the question is, what will be a null hypothesis, right?
No significant difference in mean grades. So mu
Just take your time, no problem. Yeah. If we are checking variability, that means, see, in any scenario, either we will be checking average of anything or variance, right? In the initial phase, at least. So here we are checking about the variability in marks. So variability in marks, how will you check?
oh, so
Mean or variance?
sigma 1 equal to sigma 2.
Yeah, exactly. Good. So now you have your null hypothesis. So just take what will be your alternative. Just go step by step. First, be clear with the question. Always be clear with the question whenever the question is about hypothesis testing or any probability, any statistic question or any question. First, be clear with the question, and then if it is about hypothesis testing, then just clarify, is it a one sample test or two sample test? So here it is two sample test. Okay. Then the task will be what will be our null hypothesis and what will be the alternative. So once that is clear, then go for the taste statistics. Which taste statistic will you go for? Okay, so null and alternative is clear now. So what will be the taste statistics? If we are checking in two sample test, we are checking about the variance, then we have decided what should be the taste statistic, right?
t equal to x square divided by sy square. Means reject x naught if t is greater 1 plus cr,
Yeah,
or t is less than 1 minus cm.
yeah. So yeah, in like that, you have to proceed and you will lead with some value of t. Okay, is it done? Okay. So let's start with the discussion. So yes. So there are two sessions, right? Session A and B, let's say, and what's given about that? So they have taken two sessions, let's say session A where 25 students were there, right? And what was their variance there? Sorry, standard deviation. They said that S1, let's say, okay, or SA is 12 standard deviation, right? And for B, session B,
15.
is, yeah, 50 students were there, and the standard deviation is 50.
15.
The question is whether the variability in marks of class B is greater than that of A. That means sigma B is greater than sigma A or not. That is the question, right? Isn't it? That was the question. Whether the variability in marks can be measured by variance of marks, right? So whether the variance of B is greater than variance of A, that was the question. So we will set our null hypothesis as, let's say, sigma A and sigma B are equal. The variability is same. And alternative says that sigma B is greater than sigma A, or let's say it's then sigma B. Okay? Both are the same thing. Any doubt? Okay? This will be our alternative and null hypothesis. Then what should be our test? Yeah. So let's take ratio of squares of variance, sample variance, SB square, SA square. Okay. So if you are taking SB square and SA square, then what should it be? To support your alternative hypothesis, what should be the rejection criteria for null hypothesis? Yeah. Right? We reject null hypothesis. That means we support alternative hypothesis. So if I am taking SB square upon SA square, then should it be greater than some C or less than some C?
Greater than.
Greater than.
That should be greater than some C, right?
Yes.
And let's say 1 plus CR. Why 1 I put there? Due to ratio condition. Okay, let's say 1 plus C. Fine. Is it okay?
Ma'am,
Till now.
why we are taking alternative sigma A less than sigma B? Why not it is not equal to?
Okay. So in the question, they have said to check whether the variability in marks of class B is greater than that of marks in the variability in marks of A. That's why I took the variance of B is greater than variance of A. Okay. So it's the question was not about whether the variance of marks of session A and session B was same or not. It was about whether the variance of marks in the class B is greater than that of A or not. Okay, so I took like that. And what significance level they have asked us? It was 0.05, right? So if we say alpha is probability of rejecting null when it was true, so it will be something like probability that SB square upon SA square will be greater than 1 plus CR, right? 1 plus C when H naught was true. H naught was true, that means sigma A and sigma B are same. Sigma A is equal to sigma B. So what does it imply then? What will be the distribution for SB square upon SA square? F distribution, right? We have discussed it when the ratio of two chi-square distribution are taken, then it will be a F distribution. So here SB square upon SA square, given that the sigma A and sigma B are equal, it can be viewed as SB square upon sigma A square upon sigma B square and SA square upon sigma A square, which both are chi-square distribution, and as both sigma and sigma B are same, we can cancel it out and we can say that this is the ratio of two chi-square distribution, which is nothing but the F distribution, right? So will it be? It will be F distribution with degree of freedom. Yeah. Let's say N2, NB minus 1 and NA minus 1, right? So what was the sample size for
15, so 14, 14, 11.
No, sample size.
Yeah,
Sample size was this. Yeah,
15.
14. So our SB square upon SA square will follow F distribution with 49 and 24 degree of freedom, right?
Yes.
So this part, if I write 0.05 is equal to probability that SB square upon SA square greater than 1 plus CR is nothing but F distribution with 4924, right? If it is greater than, then I should write it as 1 minus the CDF. of 49 and 24 at a point 1 plus c. I could write r. We have not taken t. Okay, is it fine? If we if it is if this particular random variable is following f distribution, then to write its CDF, I have to subtract it from 1, right? Because it is greater than 1. Sorry, greater than some quantity. Okay. Then 0.05 is given to us. So, yeah, we will just shift 1 there, and alpha is given. So, to find C, we have to take the inverse. So, yeah, it will be F4924 of 1 plus C will be equal to 0.95. Okay. Take the inverse on both sides and we'll get, yeah, inverse was given, the value for inverse is given to us. Okay, fine. Should be F. As it is F distribution, so that we denote it like that. .5. Right. That is given to us as 1.26. 1.86, sorry, 1 plus C is equal to 1.86. So, this is the value for this range, right? T. We should write it. T is equal to. So, if T is greater than 1 plus C, then we will reject null hypothesis. So, 1 plus C is 1.86. What was T given to us? So, T is what? SB square upon SA square. So, is there any information to calculate this? So, yes, the standard deviation for A and B was given to us. So, we'll just calculate 15 square upon 12 square. So, what will you say? Once we calculate it, something
1.25.
around, yeah,
1.25, I think.
1.56. Okay, some calculation about it. So 1.56, this is 1.86. Our T is actually less than C. So what will be your conclusion if I show you the case statistics? Yeah, what will be the conclusion? Our T is less than C. The conclusion will be, yeah, if, sorry, 1 plus C, right? For our setup, we got to know that this T is less than C plus 1. So we should, what should we do? Accept or reject the null. We have said that reject null if T is greater than C plus 1, right? And we solved it and we got that T is less than C plus 1. That implies we will accept the null, right? Are you getting me?
Yes, ma'am.
So accepting null will say that the question was whether the variability in marks by session B is greater than the marks by session A. So accepting H naught says that variability in marks by session B and session B was not greater than that of session A, right? So we will accept A H naught, and the conclusion is sigma B is not greater than sigma A, right? That was the question initially. So yeah, the question was about whether the variability of marks in marks by session B is greater than that of session A or not. So we got to know that they are not different. Okay, actually the marks by session B was not variability was not greater than that of variability in session A. Okay. So the answer is no here. So yeah, any doubt?
One doubt. Why we have taken 1 plus c?
Okay, you can take direct C also. The 1 plus C is coming from that F distribution. See, in last session we have discussed it. Whenever we take the ratio of two chi-square distribution, if it will lead us to the F distribution. Okay, and in F distribution, generally we have kind of things like that. So you can it's our choice. Like if you are aware that it's going to be that distribution, so you can take one. But generally, whenever ratio kind of things are there, we take such a thing. F distribution is something like that. Somewhere here we have one, and obviously, uh, the F distribution is not actually uniform distribution. So that's why this kind of stuff happens here. The 1 plus C, that means whenever we set our acceptance and rejection region, we bound it like this. So the boundaries here looks like 1 plus C and here 1 minus C. That's why we say like that. Okay. And these are ultimately our critical values. So generally we have in maximum of the cases we deal with the normal distribution and it is symmetric like this. Some mean value is there, some like mean value is there, and we say that the same C will work for both the sides. Why it is so? Because this is symmetric, right? The normal distribution. But when it is F distribution, they are not symmetric. So we just take like that.
Okay, ma'am, thank you.
So, any doubt?
In the last question, we have accepted the null hypothesis.
We accepted, yes.
It means the conditions which is given in the question, that is correct. Means it is or not. The marks variability in the marks is of B is greater than A is correct or
No,
accept.
that is not. That is not correct because in this question, whatever the question was, we have taken that as our alternative hypothesis. See, we have taken alternative hypothesis as variance of B is greater than variance of
Yes,
A. The null
yes,
was they are equal.
yes, yes.
Okay,
Correct. So since it is
so
not equal, so null hypothesis is accept. We are accepting the
we accepted null hypothesis. That means the variance is not greater than variance of B is not greater than variance of A.
means both accept null hypothesis means that they are equal. Like that what we sigma is
Yeah,
equal to. Okay.
yes, they are
Accept.
equal. We are saying, but the question was about
Yeah,
whether the variance was greater than. That's why I am saying
that
they
is
are not
not
equal in that.
not
Uh,
equal. Got
not great. Sorry, variance of B is not greater than variance of
it. Yes, yes.
A. Okay.
Got it.
So why do we do that? Because whenever such things will happen, you need uh, this. Whenever you will deal with the F distribution, you have to come up with this chi-square distribution. That's why we generally take null as both are equal or not equal like that. Or
Okay.
sometime in some question we may take the difference is equal to some, let's say the difference of variance is equal to 1 or 2 or like that. Depending on the context, we change our null and alternatives. Hypothesis.
Okay. Okay.
Okay.
Thank you.
So yeah, this was the last question. So you guys understood like what we did here. the PDF will be provided to you. Okay. So yeah, hope you enjoyed the course as it was the last topic, right?
Yes, ma'am.
Okay.
Yes, ma'am. Thank you.
Thank you,
So
ma'am.
thank you.
Thank you.
Thank
Thank
you.
you.
Thank you, ma'am.
Yeah. Thank you.
Thank you, ma'am.
Thank you.